Hi, my name is Luis Fernando Avila Giron. I'm doing this project by myself, and I choose the topic of application of Kainer's neighbors algorithm on breast cancer diagnostic. And I choose this topic because one of my uncle's wife was diagnosed with breast cancer. So I believe that it's really interesting how we apply the statistics in this specific kind of topics. The K-nearest neighbors algorithm, also known as KNN, is a not-parametric, supervised learning classifiers which use proximity to make classifications or predictions about the grouping of an individual data point. While it can be used for either regression or classification problems, it's typically used as a classification algorithm, working off the assumption that similar points can be found near one another. This method is one of the most common data mining tasks that may be found nearly every file, just as education, banking, medicine, and law. For example, in finance, we can apply 1,000 records to estimate and predict values for each stock. This research addresses the breast cancer diagnostic problem as a pattern classification problem. Specifically, this problem is studied using the Wisconsin-Madison breast cancer dataset. The K-nearest neighbors algorithm is employed as a classifier. Conceptually and implementation-wise, the K-nearest neighbors algorithm is simpler than other techniques that have been applied to this problem. In addition, the K-nearest neighbor algorithm produced the overall classification results 1.17% better than the results known for this problem. The Wisconsin-Madison breast cancer problem is referred to the presence of a breast mass may indicate malignant cancer. The University of Wisconsin Hospitals has collected 699 samples using the aspiration test. Each sample consists of the following 10 attributes: patient's ID, clump thickness, uniformity of cell size, uniformity of cell shapes, marginal adhesion, single hepatic cell size, bar nuclei, blank chromatic, normal nuclei, and mitosis. The dataset contains 16 samples, each one with the missing attribute. They have discarded the samples as has been done by the other authors. Hence, a fair comparison of the results against their results can be made. The 683 samples are split randomly in a training set that consists 190 malignant and 222 benign samples. The test set consists of the remaining 120 malignant and the 222 benign samples. The application of K-nearest neighbors algorithm in this method is for each test datum, the Euclidean distance between the test datum and all the training data are calculated, and the test datum is assigned the class label that the most of the K-closed training data have. They have experimented with different values of K from K equals 1 to 15. With the KNN algorithm, the classification result of the text fluctuates between 99.12% and 98.2%. The best performance is obtained when K is equal to 1. When the KNN algorithm is used, the classification performance varies between 99.42% and 99.12%. Using the KNN method, the result was 1.17 better than all the other methods applied in this case. The advantage of KNN algorithm are that the algorithm is very simple and its implementation is very easy. Since there is no need of any training session, there is no converge problem. In contrast, the other approaches employing neural networks maybe face the convergence problems and may need longer training time. New training data can also be added to the KNN algorithm without retraining, but the other techniques adding new training data needs retraining because the new training data disturbs the structure of the existing training set. And all the parametric or semi-parametric classifiers critical depend on this structure. As a conclusion, the good performance of KNN algorithm does not imply that the KNN algorithm will be always good for all the diagnostic problems. In fact, there is no single algorithm that performs well on all the diagnostic problems.